Okay guys, in this chapter we're going to learn about particles, particle emitters, and particle fields. This is going to be a lesson about kind of some of the special effects you can do with inside Maya. It's a small step in the large world of special effects. So far we've just covered character animation, inanimate animation. Here we're going to start covering physics-based animation and particle fields and hard body dynamics such as balls falling, dropping, things colliding with each other. But this lecture will deal with primarily particle systems. Okay? So what do I mean when I say particle system? Well, I guess the best way to show you is to go ahead and get started with the examples here. So what we're going to do, I'm going to go ahead and go to animation or polygons. These are the two menus we're used to in Maya so far. Polygon and animation. What we want to do is we need to go to this drop down menu here, and now we want to go to dynamics. Dynamics is the template menu, or the kind of general menu that changes all your little header menus up here to the respective tools that help you create more physics-based special effects within Maya. They're not all physics-based. There's some muscle systems in there. These are highly specialized systems that give you an added oomph to your production. But today we're going to be talking about emitters and particles and all that good stuff, so we can get some really neat effects going, like sparks or snow or rain, something like that. Alright, so the first thing we're going to do is we're just going to go to particles. Remember, we're in dynamics. We're going to go to particles, and we're just going to create an emitter. And in fact, if you want to go ahead and open up the extra options, so we can just go to reset settings, just to make sure we're all on the same page, I'll click reset settings and I'll just create. Alright, so now I have, if we look at our outliner here, I have two different things in my scene. I have emitter 1 and particle 1. Before I hit play and show you what I've made, I'm going to go ahead and expand my timeline. 24 to 48 frames per second is not a good enough workspace to get approximation, to approximate what our particles are doing in our scene. So I'm just going to increase this to 1,000 frames. And if I increase the total frame, or the current visible frames, to 1,000, it'll increase the total frames to 1,000 as well. So with my current frames at 1,000, I'm going to do one more thing, and these steps are pretty important, so make sure you set it up the way I'm doing it. After I set my frames up, I'm going to go to playback speed, and I'm going to make sure I'm in real time. Again, I right clicked on top of the timeline, I brought up play speed, and make sure we're in real time here. Some particle systems will not play in anything other than real time. Alright, so I'm on frame 1, and this little ball here, let me select my emitter, this little green ball we see in my workspace is the actual emitter. And if I press play, look what we get. I hope you can see this on your screen, but I'm getting a lot of purple little specks flying out from the middle of this little green dot. To help this display this better, I'm going to go to my outliner and just select particle 1. Now, with all my particles selected that my emitter is creating, we can see that they're all light green now, and we can get a better idea of what my particle system is doing. So what we're seeing right now is hundreds of particles emanating from the center of this emitter. Okay, so these are the two basic principles of particle systems. We have the emitter, which creates the particles, and the particles themselves. My time frame just went back to 1, so you can see the particle system reset itself. What we're going to do now is we're going to talk about some of the attributes of emitters and particles, and we're going to talk about how we can put in gravity on our scene to make our particles behave even more realistically. But important thing to note about how particles and these simulations work on the timeline: if I press stop and scrub my slider all the way back to frame 1, we can see that nothing's happening. No changes are being made as I scrub back to 1. But as soon as I get to 1, the simulation knows this is my start frame. It's going to get rid of everything. So, important thing to note, anytime you're working with these particle effects, you make a change to an attribute, never just kind of stop it and play it, or just let it keep playing. You want to start over at the very basic frame 1, get everything off on the right foot, square one. So what we're going to do is we're going to stop the playback, and we're going to go to our go to start of playback range. And what it'll do is it'll reset the simulation for us, because right now our settings dictate on frame 1 our particle simulation will begin. So if you make any kind of changes here in the next few weeks that you work on this stuff, make sure you always reset your settings back to 1. That'll make sure that whatever settings you just tweaked will pretty much reflect that, and you won't get confused with existing particles in your simulation. Alright, with those basics out of the way, I think it's about time we can start talking about this emitter right here. And what we're going to do, we're used to seeing our channel box right here, but we're going to go to the attribute editor and work primarily in the attribute editor for our emitters and particles and fields. And I'm just only going to touch lightly on some of the most important basic foundations of these different types of tools and effects, so we don't get bogged down with a bunch of excess information. So what I'm going to do is I'm going to go to my attribute editor. So again, if you don't have your outliner up at all or whatnot, this little folder button next to our channel box button is what brings up the attribute editor. If your channel box is up, just click the attribute editor twice and it'll bring it up. You'll know you're in the attribute editor because it says so right here. And we can see two little tabs right here, particle 1 or emitter 1 and particle shape. Alright, what I'm going to do, I'm just going to bring this down right here. The particle shape is kind of a shortcut tab that helps us tweak some of the more important aspects of particle 1, but let's not get ahead of ourselves. Let's just talk about what our emitter is doing right now and how we can start tweaking it, and what are some of the more important functions of my emitter. Well, we have all our regular transform attributes, so if I moved my emitter, you could move it, all kinds of stuff. You can even rotate the direction of it in case you want to have your emitter going to a particular place, pointing this particular place. Scale doesn't really do too much for the emitter, so don't worry about scale too much. But I'm just going to keep all my transformation attributes kind of zeroed out, very basic. I'm going to mosey on my way down here, and here we have our first important attribute setting. Omni, the emitter type here is set to Omni. If we pull that down, we have 5 different selections we can choose, and I'll go through each of these 5. But for right now, Omni and Directional will be the two we'll be primarily using for just the basic emitter. So right now, just worry about Directional and Omni. Right now, Omni means in all directions. So if I hit play, I'll highlight my particles so you can see. I can see that I'm getting particles in all directions, different speeds, different angles. It's just chaos. Alright, what if I go back to emitter? What if I pick directional? And I'm going to go back to frame 1 and see what happens. Now I'm getting my particles going in a certain direction, and they're just going to go into infinity because I haven't tweaked any of the settings yet. So it's going to keep going until it hits frame 1000, then it's going to start over. So let's talk about some of the settings that we have for both of these types of emitters. Alright, I'm going to go and mess with Omni first because that was the default setting. The first type of attribute we're going to talk about is rates per second. This basically means how many particles are created every second. So if I just want one particle every second, there we go, I'll just make that 1, and we can see how that relates. There's my 1 particle. See, 1 particle a second. 1 little green dot per second. Not very exciting, but who knows what kind of particle system you want to set up. If I create, let's do 100,000. Maya's exploding. I better stop that. Look at all these points. 1,000, 100,000 particles per second. I don't suggest doing that. 10 may be a little bit more manageable. 10 particles, so every second, every 24 frames, I'm getting 10 particles created. So, pretty good way to control how many particles exist in your scene. Alright, and there's other little settings below it, but this is the main one I'm going to touch on. You can experiment with some of these other attributes on your own time. Alright, the next thing I'm going to go to is min distance and max distance. This basically, min and max distance dictates where the particle is created, how far from the emitter it's created. So if they're both set to 0, which is their default values, they're both going to be emitting exactly from the very center of our emitter. They're just going to come straight from that center there. You know what? For example's sake, I'm going to go back up to rate per second, maybe set that to like 56 or something, just so I can see what's going on a little bit easier. So they're coming straight from the center here. Alright? What if I wanted to make them not come from the center? Well, min distance and max distance, these numerical values are in units. So if I choose the min distance at 1, the max distance at 1, then it's going to take 1 unit square that we see on the grid here all the way around it and not emit until it hits that 1 square. So there's like a square diameter kind of field around this that's not emitting from. So it's not coming exactly from the center. It's a little bit hard to see, but maybe if we exaggerate that figure, we can kind of tell what's going on a little bit better. Maybe we can do 5 and 5. Maybe we can get a better idea of what's going on. Yeah. There are no particles within 5 units being created to my emitter. They're all kind of being created around it as a shell. Alright. So that's what that does. And you can create some kind of type of randomization. So I want my min distance to be, let's say 5, and my max distance to be 20. That means any value, unit value between 5 and 20, a particle will be created at random. So if I start it over, we can see that they're just being created all over the place around the emitter. Alright, that's a pretty important little thing right there. I think I'm just going to go back and set this at 0 and 0 for right now. Notice these other values are not highlighted. These values only correlate to directional emitter, and we'll come back to those in a second. Our speed basically dictates how much velocity each particle has when it comes out of my emitter here. So if I set my speed to like maybe 0.2, we're going to see a very different particle system going on. Notice how the field is more tightly knit. They're not moving as fast. That's because their velocity or their speed they're moving is vastly reduced. Alright, so let's do the opposite of that. Let's take our speed and set it at 2 and see what happens. Particles are a lot faster. And if it seems like some of the particles are moving slower than the others, that's only because perspective's playing with your eyes there. Since this particle is moving into the distance here, it looks like it's moving slow, but trust me, it's just kind of moving slower because it's going into the distance rather than flying off at a completely right at the screen. So that's why the speeds are looking a little different. I guarantee that all these speeds are constant. But if we did want to add a little bit of random speed to it, let's go and set this value back to, let's say, 2. Or let's set it up to 4. And let's add in a speed random. Let's say that, let's go with a speed random of 5. Let's see what happens. And I'll select my particles so we can see them better. So what I'm seeing, some particles are going faster than others. I think what I'll do is I'll demonstrate this a little bit better when we're using our directional emitter. It being Omni, the particles are going in different directions, different perspectives. It's going into the depth. So it's not the best way to see kind of how the speed's working there. So I'll come back to that with directional, if that makes any sense. But what I will do is I'll go back and set this at 1 and set this back at 0. So I can get a nice 1. Make sure I press enter there. There's my default particle field back. Alright, great. So all about emitters, huh? Yeah, and you can also change some of the particle colors here that display on the screen. So if you want to have a little bit easier time seeing them, maybe you can change it to red. And let's see. Yeah. And I think this mainly relates to how they're rendered in the renderer, which I'll show a little bit later. maybe in the second lecture or whatnot. So that's the Omni uh, emitter pretty much. Let's go back and look at directional real quick. All right, there's our directional, and after directional, we'll cut this lecture short and maybe hit up some other things in our next one. So directional spits out my particles pretty much in one direction. All right, so I'm going to lower this particles per second maybe to 15. We'll start my simulation over just so I'm not getting so many particles. And maybe we can do some crazy things here. What if I rotate my emitter now? Notice how when I rotate my emitter, I'm going into another direction. Now I'm going up. Let's pause it and let's just completely change the script here. Now I'm going to the left and kind of down. So the rotation of your particle field does matter for the directional type of emitter. But let's just go back to our transformation and just set these rotations back at 0. Or maybe I guess we'll have to go to our channel box. We'll just 0 these out. There we go. Go back to my attribute editor. So that does demonstrate that the rotation of your emitter will dictate the direction of your directional. Alright, great. So now we have a few more options opened up. We still have our min and max distance. So let's demonstrate that. Some of these values will be a little bit easier to demonstrate on directional since we just have them all going to the right now. And that's perfect. So let's set our min distance at 2. And let's set our max distance at like 4. Alright. So in between these two squares is where my particles should emit from. And that can be easier to demonstrate if I reset it. So in between these two particles, so we go 2 units out. So this is the second one, this is the minimum distance, and 4 is the max. So in between these 2 units is where our particles should emanate from. There we go. Pretty neat. So min and max distance really at work there. Now we can also, besides rotating our emitter, we can also change their direction with the direction attributes right here. So if I wanted it to go up, I just make my x value 0 and my y value 1. And now my emitters should be going straight up in the air. See what happens if I don't reset? My existing particles that were shooting at a x value of 1 are still going, and now my y particles are going straight up. So if I reset that and go back to frame 1, I'm only going to have my y particles going up. So that's another way we can set direction for our tool here. I'm just going to set that at 0. What happens if we don't give it any direction? Well, I bet no particles will be emitted. Yeah, they just kind of stay there in the center and don't go anywhere. So you don't want to do that. You want to make sure that your particles are going at least one direction, and one is just a good good example of how to do that. All right, so my particles are being emitted from a minimum distance of 2, a maximum distance of 4. They're going in the positive 1 direction in the x axis. Spread is another very important one. Let's give it a spread of 5 and see what happens. Or I guess it's normalized from 0 to 1. So if we give it a 0.5 spread, I'll give it a 0.4. I guess it doesn't matter. We see a very different thing going on right now. Now my particles are spread out. And in fact, they still emanate from the center here. They just don't show up till here. So you can trace their spread at different angles, tracing back to the center of my object here. If I go and reset my minimum and maximum distance there, let's say 0, 0. So 0 and 0, minimum, maximum, they're coming from the exact center. And now I can see my particles are coming from the exact center here. There we go. Alright. So not too many more things here. Speed, random, and speed. Here's another good example to, using directional. I can show this attribute a little bit better. So first going at speed 4, and let's give it a random value of 1. Alright. So they should be going a little bit faster, but they should also be going at different speeds. Alright. So it doesn't look like they're going too much slower than one another. So let's bump up my... Anytime you see me going back and forth here, I'm having to get back to my emitter and my outline to get back to these attributes. So I can show them off better in the lecture. I just highlight the particles. So I'm just going back and forth between those. Let's increase my speed random to say 10. Let's see what happens. Alright, we are getting vastly different values here. We're getting some that are going really fast, some that are really slow, and even some ones that are kind of going in the negative direction here. Let's do a theory. Let's set our speed random to 4 and see if we can cut out some of those particles going in the back there. We do, in fact, do that. And we still get some random speed going on. So let's set our speed random at 5. One more unit past our overall speed. Let's see what we get. Okay, getting a little bit more random. So I would assume that the higher the random, the more chances that you're going to have these particles kind of shooting back in all kinds of different directions. And it's almost like they make the speed go negative in some instances. So that's a pretty nice little way to add a little bit of variation to your particles. Alright, so that kind of wraps it up for right now. We got a basic understanding of how emitters work. We've looked at directional and omni, two very basic ones. You can do a lot with them, and looked at some of the more basic attributes with them. In the next lecture, we'll look at emitting particles from actual objects like a square or a curve or any kind of surface at all. We can emit particles from that. And we'll also look at some of the attributes for the particles themselves. All right, thanks.